Okay, now I would like us to look at reactions, redox reactions, balancing redox reactions in acidic medium, alkaline medium, and then we find out which of the species has oxidized and which one is acting as oxidizing agent and which one is acting as the reducing agent. Okay, we look at it now. Balancing redox or ionic equation. Okay, now we are going to look at the simple redox reaction. Those are a simple one before we look at it. Balancing some of them in acidic medium and then alkaline medium. I would like to show you the simple redox reaction between iron and maybe chlorine and chlorine Cl. And then small I'm having here 3 of these coming over here, and then maybe this here gotten here reduced. I think you can pause the video and see if you can answer the question here. Very simple. Which of these two are the oxidizing agents? Which one is the reducing agent? You can pause the video and give the answer. To me, I think iron here is oxidizing agents. Chlorine here, oxidizing agents, reducing agent. Why? This was actually oxidized, this was actually what? Reduced. Having gained an electron, this will reduce. Having lost electron, this will oxidize. But what we are looking at is this reaction or equation balanced? I don't think so. In redox reaction, you must balance, there are 2 laws, chemical laws that must be obeyed. I've stated before in my video that you must try to obey the law of conservation of mass and then the law of definite proportion. And when you are trying to conserve the law of conservation of mass, you must make sure that the number of moles at the left must be equal to that of moles at the right hand side. That is when law of conservation of mass is obeyed. And when you obey the law of definite proportion, when you have the right formula of the compound, that's when it is obeyed. So that these 2 laws must come together in an equation like this. But since this is redox reaction, when I'm trying to obey the law of conservation of mass, I must make sure that the reactions must be balanced atomically and at the same time ionically. Yes. The number of atoms of iron must be balanced. In this reaction, it seems as if it's balanced. Very balanced. Then the number of charged on this side must be equal to the number of charge this side. There are no charges here, but there are sum of 3 minus 1 here. So we have minus 2 charges here where this side is 0. So that means this equation is somehow faulty. It is not balanced. It's not balanced again because chlorine can never be written in this form. So it must exist as molecule Cl2. Very important to know that. And even if you try to manipulate, okay, since this is 2 and you are trying to put 2 here, okay, that is good. What of the charges? Remember that the sum of the charge of iron here is 0 since it's not combined. This is equal to 0. 0 plus 0 is 0. Here is plus 3 minus 2 is minus 1. So if here is 0, here is minus 1, this equation is not balanced. How best to balance this equation is to half it, to split it into 2. One for oxidation, one for reduction. How we split it? So since here is 0, and here is 0, and here is plus 3, and here is minus 1. What do? I know that from here to here is oxidation because there has been a change from 0 to plus 3. From here to here is reduction. So here is oxidation, here is reduction. So there has been a change from 0 to minus 1. 0 to minus 1. So what do I do in this case? I will split this equation into 2 half cells. Starting from oxidation, you have Fe going into Fe 3 plus. Atomically, ion is balanced. Ionically, it is not balanced. What do I mean by that? So since here is 0, here is plus 3. So that means both sides must be equally charged. What do? I know that if I gain an electron, going backward, ion will reduce to 0. That is, gain of electron is reduction. Okay, so I know that this side gain an electron, it will balance. How many electrons am I going to gain? Depend on the charge here. So I'm going to gain how many electrons here? 3 electrons because of this 3. So if I have 3 electrons with the symbol of electron here, total number of charge here is minus 1 times 3, minus 3. Now that we have minus 3 here, minus 3 plus 3 is 0. So technically, this equation is balanced. I can just call this equation 1. And then I'll bring this one out as reduction, which I have a Cl2 and then 2Cl minus. Here is 0, here is minus 1 times 2. Total net charge here is minus 2. So that means it is not balanced. And I equally know that since this is reduction, and then that the reduction is the gain of an electron. So for we to have this reduction, that means if I need to gain electron here for this to be reduced. So how many electrons I'm going to gain here depends on what is here. So since the total net charge here is minus 2, what goes there will be what? Plus 2e minus. So that minus 2, minus 1 times 2 is minus 2. Minus 2 plus 0 is minus 2. So it seems as atomically and ionically this equation is balanced. So now that this is balanced, I can just call this equation 2. I will check the electron gain in equation 1 and electron gain in equation 2. They must be the same for this equation to be balanced. Here I have 3 electrons here. Here I have 2 electrons here. It is not the same. What do? I have to multiply this electron gain and loss. So here in equation 1, I'm going to multiply everything here, coefficient of everything here by 2. Coming down to equation 2, I'm going to multiply everything here by 3. So here, 2 go here, I have 2Fe, giving me what? 2Fe, 3 plus 2 times 3e minus is what? 6e minus. Okay, then 3 times 2 here is 6e minus plus 3Cl2. What goes here is what? 6Cl minus. Let me call here equation 3. Let me also call here equation 4. Equation 3 and 4 is half cell. Equation 3 is half cell oxidation, half cell reduction. So if I have to go and get the overall reaction of this, that means I'm going to add the 2 equations together. But before I do that, anything I see here that is the same, I have to cancel. So this 6 electron will cancel this 6 electron. So having the reaction from reactants from this part, we have 2Fe plus 3Cl2. What we have here is what? 2Fe 3 plus 6Cl what? Minus, let me call it equation 5. That's the last equation to this. But I always want to check 2 things in this reaction. I'll check if the atoms are balanced. I'll also check if the ions are also balanced. So atoms first. How many ions do we have here is 2. We have 2 ions here. Forget about the charge for now. We check the number of atoms, whether it is balanced before we go to charge. Here we have 6 chloride, 6 here, 3 times 2, 6. We equally have 6 here. So we have the total net charge here is 0. Ion is 0, so 0 times 2 is 0. So here is 0 plus 0. Total net charge is 0. Here we have 2 times plus 3 plus 6 minus 1. So we have this as plus 6, we have this as minus 6. So plus 6 minus 6 here is what? 0. So both sides is atomically and ionically balanced. This is how to balance redox reaction. These are the simple ones. You can pause the video and try and see if you can articulate with this analysis on how to balance redox reactions atomically and as well as ionically. Okay, now that is done. I would like to give one example that will be how to balance redox reactions that are having oxoanions. Yes, redox reactions bearing oxoanions in acidic medium.